Hi everyone, welcome to the 40th webinar in 12D's training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capabilities of 12D products. We run these webinars regularly and record them for posting through our website and on YouTube. The first 39 webinars from this training series, as well as the webinars from our Industry Solutions series, are available on our YouTube channels if you missed those. While we wait for everyone to finish joining and get comfortable, I'll launch a polling question. You'll have about 30 seconds to answer about your experience in Drainage 2D, and then I'll show the results. Okay, it looks like we've got a bit of a mix of attendees today, including some people who are quite new to Drainage 2D. So welcome everyone, I'm sure you'll get a lot out of today's webinar. During this live presentation, you'll be able to type your questions along the way. We'll put some instructions on the screen. We'll answer as many as possible of those throughout the webinar. At the end, I'll also read out some of your questions to the presenter for his insights if there's time. Today's webinar, Drainage 2D Advanced, will be presented by Rob Graham, our resident water resources engineer, with 20 years of experience here at 12D and over 30 years of experience in the industry. In case anyone's not aware, our 12D Technical Forum is on in Brisbane this July, and the Associated Innovation Awards. The closing date for those is the 30th of April, so enter now for a shot at an amazing prize. Roadflow is just the start of TUFLOW modeling inside 12D Model. When advanced modeling is required, it's time to move on to the advanced tools. In today's webinar, we'll look at the TCF Editor, cell sizes and updating your grid tin, TSE, the TUFLOW String Editor with 12D elevation versus GIS attributes and visualizing wide Z lines, TUFLOW empty files in 12D Model, message and check files visualization, monitoring results live for long TUFLOW runs, legends and results, behind the scenes of the TUFLOW command file and 12D model and TUFLOW file relationships, timelines and visualization. Over to you, Rob.
Yeah, welcome everyone, and thank you for that, Lisa. Yes, welcome to the 12D Model Drainage 2D Advanced Training. It's going to be the first in a series of 2D training. When we're putting this program together, we started to list all the different topics we wanted to cover, and there was really no way that we could even think about covering all that in an hour. So, and then after reviewing the material, I reviewed the word advanced, and I thought, intermediate might have been a more appropriate word, because advanced 2D modelers really almost have a lifetime of experience. And for those people to call this advanced modeling, I thought might be just a little bit understating what they've achieved over the years. So we really are just saying goodbye to Roadflow today, which I refer to as 2D modeling with training wheels on, knocking some of those training wheels off, and then adventuring a little bit more into the 2D modeling world. So Lisa read off of several of the topics we're going to cover today. And for those of you that haven't been to any of our 2D webinars before, I highly encourage you to get yourself across to the 12D website. So let me just move across there just for a moment. On our 12D website that Lisa referred to, we have a section on our webinars. And if you do click on that webinar section and just scroll down a little bit, of course, we tell you what's coming, which is all very interesting. But then after that, there's a small blue title that says Previous Industry Solution Webinars. And I find that's a very good place to go look up the ones that we've already done. In particular, I'd like to draw your attention to the Roadflow webinar. If you haven't seen that webinar and you are just getting started, you just haven't done any 2D modeling yet, that Roadflow is an excellent webinar. Alan does a great job of taking everyone through the different components. And as a matter of fact, after reviewing that one, I saw what he had done with the timelines and what he had done with the legends, and thought, well, let's just leave that out for today. So hopefully that wasn't what everyone came for. You'll find at the very end of that road flow, you'll find those topics covered very, very well. So please refer back to that one for some interest or any extra information you want on the basic tools. So let's get into the subject matter for today. Starting with road flow or an existing project. When you are planning to start using the TCF files, and we'll talk in a moment more what those are, those might have been created by Roadflow, which is probably where a lot of you are coming from if you're in the 12D scenarios. Or if you created them yourself, you might be a TUFLOW modeler who has developed a TCF file all by yourself, and those you'd like to bring into 12D. Well, the long and the short is you can just drag and drop the TCF files into 12D. So let's jump into 12D model and take a look at that. So the first thing I'd like to do is I'm going to use our Explore button, which takes me to the working folder underneath our 12D project. And this is where Roadflow naturally creates the folder structure that has all of its information in it. But if you created your project outside 12D, this is where we'd like you to copy that information and keep it. The reason is that 12D wants a relative path straight down to your data. And so if you have an outside project, please bring it into your working folder. So this one was created by 12D. And so if we did use the exact same folder structure, we call it the classic structure that the TUFLOW users like to use. So if I move down to our runs folder, you'll find that that's where 12D has created our TCF file. Now the TCF file can be simply dragged and dropped into 12D, and it'll open up for you. Now that's one way to get to it. Of course, you could just go to our design down to TUFLOW, our TUFLOW menu, and choose it off the TUFLOW menu. I tend to pin up my TUFLOW menu, especially when I'm doing training. It makes it really easy for everyone to see the words for the commands I'm about to use. So back to the TCF editor. Now the first thing that we do is generally hit the read button, but nicely done when you do a drag and drop is that it already shows up for you. So what's different about the TCF editor than Roadflow? Well, let me put them side by side and then you can get a bit of an idea. So I'm going to go bring up my Roadflow project or panel that was used in order to create this. And as we go through, you're going to recognize many of these settings that we've used before and all of these optional data settings as you see them inside the TCF. One of the things that happens when you hit the run button is Roadflow erases the entire folder. So every time you hit the run button, you are starting fresh. That is not the case with the TCF editor. With the TCF editor, what you're doing is you're starting with a base project or model, and you're building on it. So you're frequently adding additional layers, extra bits of information. And when you add those extra bits of information, you don't want to write or start over, you're building. So that's the big difference. We're no longer going to erase everything every time we hit the go button. So let's now go back and take a little bit, we'll take a look at how exactly we do a run. So we've already read in a TCF file. When we're ready to go, we can just hit the Run DP button. And you'll notice there's two buttons down there. There's a Run SP, which is single precision, and the DP, which is double precision. In version 12, now that's what I'm running here. I'm running what's called a pre-release. We're just about to release our version M for Michael there. And in version 12, if you're going to run it with our 12D pipes, we ask you to use double precision. If you're not using our 12D pipes, our drainage system, then you're more than welcome to use the single precision runs. So you can see this is a fairly small project. When we do our training, we like to keep the data set small so that we can do the runs. And this one solved in approximately 35 seconds or so. Once it's finished, we do something very similar with Roadflow. We come in and we select the Read Results button. The Read Results, once again, takes you to the log file, because that log file is an absolute goldmine of information. If you start to have trouble with TUFLOW and you don't understand what's happening, this is the place to go. So now we've selected the log file, we can come in now and select Read Results. And that Read Results would do almost identically the same thing as the read results in Roadflow. However, it does not read in the check files. We give you a second option button over here if you want to read in those check files, and we give you additional controls for reading in those check files. So once again, I'll hold off and I'll come back to that a little bit longer later when it's time to talk about check files. But that gives you a very basic introduction to the TCF editor and how we run TUFLOW, just like we had to run TUFLOW from the Roadflow panel. Now, the TCF editor itself. The moment you start loading up the TCF editor, you're going to find a lot of commands that may be quite foreign to you. And they are going to need some very good explanations. The place to go for this is the TUFLOW manual. The TUFLOW manual really is the Bible that you're going to go by when it comes time to find out what's happening, what commands are needed, exactly what values you're allowed to use. It's all there in your TUFLOW manual. So let's take a look at this wonderful document. It comes inside in PDF format. You're more than welcome to head across to the TUFLOW website. That'll be tuflow.com. And you'll find you can download it there quite easily on the download section. It's just a standard PDF. One of the things I like to mention to people that aren't used to using online documentation is, especially with the PDFs, don't be afraid to use these little call-out buttons. Because when you find something of particular interest, it's so good to stick a little marker on it, say a little bit of information. This was really interesting. And then you post that. And then later, you've got all of these places to jump back to. So really, really encourage you to use those. And do remember to save them afterwards. And of course, on this side, you've also got your, what I refer to as a toilet paper roll, which gives you access to your table of contents. One feature that many people don't use with PDF is Control-Shift-Find. That advanced find takes you to a find that gives you a lot more control over what you're searching for, especially things like whole words. And when you do a search, it will find all the occurrences inside your document at once. So that's just a quick, I realize it's not a training program about using Adobe Reader, but those are good features to have. Now, back into 12D. Yes, the next is the link between a model, so that's a 12D model, and a file that TUFLOW will read. So let's jump back into 12D and let's look at TCF Editor. All right, over on the Editor tab, the first thing you'll notice is that it's a tree structure. You can expand and contract the tree. If a branch on the tree has sub-items, that means it's a file that sits inside your computer and you can open it up. If it doesn't have a plus sign beside it, then it's a single TUFLOW command. Now, we think this is a great editor. It's got all kinds of functions where you can copy and paste and move your commands up and down. But there are some TUFLOW modelers who really would rather use the favorite text editor. And for those people, please use both. If I was to go back to TCF Editor, I could come up here and I could go open. And I would be more than, that's going to open up Alter Edit, which is one of my favorite editors. And it's going to bring exactly the same TCF that I was looking at inside 12D. I'm welcome to make all the changes I wish here. There's absolutely no trouble with put extra spaces in, because when we work with it, we will maintain your spaces in your indenting. Once you've saved it though, highly do encourage you when you get back, as a matter of fact, it's very important to hit the read button again so that you've read the updates that you've already made. Now, if we move down, of course, in this 1 hour, there's no way that we could possibly go through all of the commands that TUFLOW has, but one of the basic files in the structure is your geometry control file. Now, once again, because it's a file, it's got the plus sign beside it. So if I was to expand it, I would see all the commands. Now, for those of you that remember Roadflow, there's one of the commands that you might remember. We asked for a cell size, and that's where that cell size has been entered into the project. If I move down for something else that you might recognize or might not recognize, is the time step. When you ran Roadflow, we never asked you the time step, and the default was always 1/2 of the cell size. Well, now you have the option to change that. And of course, you can see it'd be easy enough to come over here to the side and change the values. So it's a very straightforward editor to use. And one of the beauties of using this editor is that when you select the command, immediately on the right-hand side, we will give you the options from the manual. At the end of this presentation, we'll take a look at the file that controls this editor and allows you to add extra commands that may not be in the editor at the moment. So that was a brief introduction. One of the things I wanted to talk about was the relationship between a model, a 12D model, and a file. So what you'll notice here is that there is a 12D model, TUFLOW materials. Now this is the file that is created by Roadflow when we wanted the second end value. Now when that is stored from inside 12D, it has to be written out. And we highly encourage all of our modelers to use the same name for the model as the file. Now officially it's not required, but it sure makes understanding things a whole lot easier. So keep that one-to-one relationship between a model name and a file name intact, and your modeling will go a whole lot easier. So now I've already mentioned about the TCF or the text editor. Once again, it's your choice which way you want to go and use the combination between them. So now let's take a look at these attributes. The world of TUFLOW began with GIS, and GIS was the way that information was stored. And the GIS systems run on attributes. So let's start taking a look at attributes inside 12D. And let's start taking a look at them in a very, very simple condition. So I'm moving back into 12D, and I'm going to go over to a view that I've created called 12D inputs. And if I went up to the minus button, you'd probably recognize some of these names that we use when we do the road flow. Things like the grid extents, the gullies, the materials, the ridges, and in this case, it's our 1D culvert. Well, in the background, there's a few other models that get created. So let's go take a look at those. I'm going to go to my plus button, type in culvert, which was the name of my TUFLOW grid. And you'll notice down here, there's my TUFLOW grid, but there's three other models that were created: active areas, exterior boundary conditions, and rainfall. Let's add those on. And where you'll see them pop up is just inside our extent. So they're just a little bit inside. 2 cell sizes actually to be inside, to be exact. And what I want to do is take a look at the attributes that 12D put onto those models. So I'm going to select my F8 key, and that's my shortcut to the string attributes. If you prefer menus, of course, you're more than welcome to go up to strings, properties, and down to attributes, and you would get exactly the same panel. So let's go pick, in this case, I want to pick the active cell. So there's my active areas, and if I pick and accept that, GIS people and modelers are well and truly used to seeing this. They've got a attribute name, it's got a type, and in 12D we'll be using the integer, the real, or the text. So we're using a subset of these, and it has a value. And in this case, the value was to turn all the cells on inside that. So welcome to the world of attributes inside 12D model. Now, the place that was actually used inside our TCF file was up here. There was a command there that said set the code to be 0. So there's our set command. We wanted to set the code, so it's got the tick box. You can see there's many other things that we could set, and the value is set to 0. So that turned every cell inactive inside our entire project. Then what we did is we used our active area polygon, in this case is a rectangle, with the code of 1 in order to turn all the cells that are inside this rectangle back on. This is a very standard way of setting up a TUFLOW model. So that's the introduction to attributes. It goes a lot farther. Let's start taking a look at how elevations, a very core property of 12D modeling, and how that gets across to GIS attributes. When 12D started in the TUFLOW modeling realm, we figured that there had to be a very easy and efficient way for all of our elevation data to find its way to GIS and into the TUFLOW models. So let's take a look at how 12D does this, and we'll do this by taking a look at a ridge line. So we'll come down once again, we'll use our pick button on here. Now, one thing you will notice about the attribute panel, it's one of the few panels inside 12D that doesn't collapse when you use the pick button. So there's the ridges. We'll go pick and accept that. And the first thing you'll notice is we get a new set of attributes. Now, for you experienced TUFLOW modelers out here, besides maybe getting a little bit bored by now, you've just seen something that you would truly recognize. You would recognize this pattern of 3 reels in a row followed by a text, and these names are the names that we've extracted from the TUFLOW manual. The thing that would look very strange to a TUFLOW modeler is they would see 3 zeros in here. That would be very irregular. What we want to do with 12D model is we want a way to get the Z values from our strings into the attributes. So if I came down to this ridge line that we've created and I went and toggled on my Z values, you'll see that there are elevation points along that line. Those are properties of the line. They are not attributes. So a conversion has to take place. Let's move down to this mysterious TUFLOW group. One thing you need to know about groups is 12D will not export a group to TUFLOW. So if we create extra groups, we can store all kinds of information, knowing quite comfortably that the only information that will be sent to TUFLOW is information that's at the base level, not inside a group. So let's investigate more what this group is all about. Now, this is a 12D invention. So if you're new to 12D and the TUFLOW interface, it's the first time you've seen this. What we've done is we've created 3 integer attributes. And this first one that says Z from the string, when it's set to 1, what that tells 12D to do is do not use the value here, this Z value. Instead, go look at the string and get the elevations from the string. Now, 12D strings have different ways to get elevations. Sometimes they can be constant, sometimes they can be varied. But we've taken care of all those cases, so no matter what type of superstring you have, we will extract the elevations, turn them into attributes at the moment we do our export. So that's the power of this one, it's 1. I'm going to skip DZ for a moment and come down to the shape or the width. What this says is that the width value, which comes into the whole issue of thick, thin, and wide Z lines, or Z shape lines, it's not supposed to be taken from the attribute either. It's supposed to be taken from the string. So let's take a look now on how one might assign a width to a string. And we're not going to use the width one up here, okay? We want something that's actually measured in meters. So we're going to use the height feature of a superstring in order to model a width. Now keep in mind that if you were a traditionalist and you were a TUFLOW modeler that says you want no part of this, then you would just come and set these 2 values to 0, and you'd be back to the very conventional TUFLOW modeling ways. So what we're doing here is now we're taking a look at how to use the pipe property to establish the width on a superstring. So the first thing we need to do is to assign a width. So let's come and take a look at that. So we'll go across to our utilities, down to superstrings, and let's head down to pipes. Now, one of the things that I frequently do, and people that have been in training with me know that I do not like filling out panels. And so what I'll usually do is I'll set my most common settings first. And in this case, when I'm using this panel, I definitely want to set a constant diameter. Okay, now in this case, the diameter is going to be converted to a width. And that's generally what I want to do. Now that diameter value will change, so I'll generally leave that blank. I tend to use the replace option so that it just updates the string. It doesn't take a copy of it. And that's usually my most desirable settings. But once I've set those up, I'll click on my icon in the top left-hand corner, go down to my defaults, and I'll write them out. And once again, the reason I do all of this is that the next time I need that panel, I just have to go utilities, superstrings, pipes, and I'm pretty well ready to go. So back to the issue of setting a width. Now with with Z shape lines, if you give them a width anything other than 0, that's the flag to TUFLOW that you want a thick line. Now thick lines are something that are used for ridges, they're not used for gullies. So what I'm going to do is I could come down here and put a diameter in of 0.1, so quite a small number. My model, I'll use my middle mouse pick button here, and I will pick my string that I know happens to be a ridgeline, and I'm going to hit the change button. And if I zoom in a little bit closer, you'll see that all of a sudden there's 2 lines there, and those are 0.1 of a meter away. That's the way I'm going to model a thick line. And really, that's all I need to do. One is enough to trigger it. I have a hard time seeing that when I'm zoomed out. I've got a 5-meter grid cell, so I can actually make that quite a bit bigger. I can make that up to 2 meters and hit the change button, which makes them a lot easier to see. And still, that will only trigger TUFLOW to do a thick line. Now, I'm keeping in a bit of suspense as to what exactly a thick line is, but that will stay at a thick line until I put a diameter of greater than 1.5 times my cell size. And if anybody was listening way at the beginning, we had a cell size of 5 meters. So anywhere up to 7.5 on this, I'm still going to be working on a thick line, and I won't have moved into the wide lines just yet. So we've done this. We've hit the change button. We've seen it up there. Now let's go give it a run in TUFLOW, and so we can visualize what we've done. So I'm going to bring this one down. I'm going to put this one away just for a moment, our TUFLOW String Editor, just to clean up my screen. One thing about doing our presentations is that I only have one monitor, and that does definitely restrict the real estate that I have to work with. So now what I'd like to do is if I come down here to this stop command, our Roadflow puts that in because frequently TUFLOW modelers who are developing a model will not want to run the entire model, but they would like to just stop after the elevation work has been completed, or the geometry. So what we have, we put this command in, but you'll notice that it's not enabled. It's got that little, well, it looks like a bit like a stop sign, but this actually means that it's not active. So if I go and make that stop active, that's the first time I made a change to the TCF file. So the moment I make a change, I'm going to have to write that out and hit the replace button before I go do a run. So now that that file has been updated, I'm ready to go run TUFLOW. And when I run it this time, it's going to use an updated ridgeline. Okay, so let's go do that. Let's go run the DP on that. And you'll see it runs, and then very, very quickly, it's gone and reached that stop command. So it's gone and halted on us. So let's go OK for that. And now what I'd like to do, I don't have any results to read in because I haven't actually solved anything, but I have done work on my check files. So let's go read the check files that have been created. And in order to read check files, you have to pick the log file first. So let's go read those check files. All right, check files have been read. Let's go take a look. Let's see what we now have. I generally create myself another view for taking a look at those check files. So I'm going to go up to View, down to Create, and create myself another plan view. And I'm going to call this 2D CHK for check. Now, the first thing I would like to do is I've been working on that ridge line. So I'm going to go and add on that model, which was my TUFLOW ridges. Oops. There we go. And there's that ridge line that we were working on. Now, you'll notice this time it comes up as a dash. One of the things you have to be very careful of when you use superstrings with the pipe properties, if they have a line style, we'll show you the line style and not the pipes. So I'm going to go up to the toggle button. I'm going to toggle off my line styles, and then I'm able to see that pipe property again. So let's see what that's done. So let's go to our plus button now, and I'm going to ask for the check files that I've put 12D read in when we selected recheck files. The one that I'm interested in is the Z shape Z point check. Let's add that on. And you'll notice that we get a band. Okay, and it's a band that kind of jiggles back and forth. Okay, and those elevations that have changed seem to be a little bit scattered. They don't stay inside what I drew here. And what it does, this is what TUFLOW goes and does for us, is it goes and finds the cell that this ridge line runs through. And when it's a thick line, it will raise the edges and it will raise the sides. So, sorry, the sides and the centers. All of them get raised. Now, that's the effect of changing the thickness from 0 to some number between, well, greater than 0 and less than 1.5 the cell size. Now, when I'm looking at this, it would sure be handy if I could see the grid on there as well. One of the options we have when we go into our our TCF editor is we get an extra tick box to read in the grid. Now, the reason that I'm going to hit the read check files again. The reason we can give you an option for that is that creates a single string for every single one of our cells. So that's a lot of data. So generally, I only read in my grid if I really want to take a look at it. Well, I do, so let's take a look at that. I'm going to go to my CHK files again, and this time I'm looking for my grid check file. So I'll come down, there's my one to boundary kit. There it is right there, my culvert GRD for grid. And if you take a look there, it becomes more evident exactly what TUFLOW has done. You can see that it's gone and taken the cell that this line crosses, it's gone and raised the edges, and it's gone and raised the centers. Now, if I zoomed in a little bit closer, if there was a triangle around this cell center, I know that its elevation would be changed. If there's no cells, and by this time I'm going, well, wait a moment, I'm not seeing any symbols anywhere. We used to always see a little triangle around these. Now, we also before went toggle Z values. Well, Z values are there. Unfortunately, I do need to come back just for a moment, toggle my line styles back on, and now I'm able to see those little triangles again. So there's definitely pluses and minuses to those line styles. So now that I have my line style back on for a moment, I do want to see the cells that are raised. And once again, if we do like what Dylan described before, if I did a string inquire and went to that ridge line, I would see that the elevation of those cells is, or sides of the cells, is exactly the same as the perpendicular drop onto the ridge line. So a little bit of the introduction. When we move from a thin line, which is what Roadflow uses all the time, into thick lines. And of course, one of the things about thick lines is that it raises two sides, not just one, but it also raises the center. And raising the center of the cell, if you go back to those first descriptions of 2D modeling, when you think of an ice cube tray, that changes the storage in the model. So raising that cell reduces the storage inside the model, raising the cell center. All right, so that's a little bit into Z lines. Now, the next step up when we start talking about thin lines, thick lines, and then the next one is wide lines. Now, wide lines start taking into effect as soon as we get greater than 1.5 the diameter. So let's see what that looks like inside 12D. So I'm going to use exactly the same panel. And remember that I had 5 meter grid sizes. I'm going to multiply that by 1.5 to get 7.5. And I'm going to go a little bit bigger. I'm going to go to 7.6 and hit the change button on that. Now I'm going to return here. I'm going to toggle off those line styles for a moment. And now I can see that I've got a much wider pipe there. And once again, the reason we used that pipe was so that we could visualize the thickness of that. And it comes time to run TUFLOW again. So you'll notice I'm not bothering rewriting out the file. The reason is I've changed the input data. It's always written out. I only need to rewrite the file if I change the commands or the values. So I'll go run that again. It's going to hit the stop button again, stop command. So I'm going to go finish. I'm going to go read in a new set of check files. Now, if I was a little bit more on the ball, I could have turned off that grid and saved myself a moment of reading. And now you'll see that we get a different pattern altogether. We're not getting the edges and the cells. What we're getting is a band. So let me get rid of that grid for a moment. And now you can see that a pathway or a swath has been cut. And it's the cells edges and the cell centers that are within this band, which is very well visualized by the pipe diameter, that get changed. So welcome to the more advanced world of Z-shape widths, a wide, a thick, and a thin. So the thin creates a barrier, does not change the storage. A thick only works on the cell that the ridgeline goes through, and a wide actually defines a band within which the points need to be changed. So quite a bit of difference, gives you more power when you're applying those features. One thing I would like to mention before we leave that is that if you do want to return that to the thin lines, you would just come back down here, change your diameter back to 0, and then hit the change button. Okay, so that was probably a fairly good example to explain to you the ways that we use the power of 12D's properties and visualization in order to create the 2D modeling. Now, what I have shown you so far is using the standard 12D attribute editor. One moment. That attribute editor is phenomenally flexible. It's used by all kinds of users of 12D model. But now we're going to look at a more specialized attribute editor. It's the TUFLOW String Editor. So let's jump back into 12D just for a moment. I'm going to turn off, actually what I might do is just go back to our Inputs tab. Sorry, View, a little bit bigger. Go back close to this ridge line that we were looking at before. Actually, what I might do is take you back to that original one, which is our active one, active cells, and go to our TUFLOW String Editor. You can see that we're slowly making our way down the TUFLOW menu, looking at those tools that were not used inside Roadflow. So the TUFLOW String Editor, I'm going to use the pick button. I'm going to come down here and I'm going to select that active area. Now, if you remember when we brought up the active area before, we had that name code. We saw the one there before, and there was the mention of an integer in between. So when you use the 12D attribute editor, you had to be on your toes. You had to know that that one attribute had to be the first attribute, and it had to be an integer. That pattern is what TUFLOW looks for, and it has to be maintained. The TUFLOW String Editor knows that, and it knows what the purpose of this model is. It's only to contain code values, and so that's why it knows what to give you in this case. So pretty straightforward. It just makes things a little bit simpler. Well, let's go take a look at a string that has a little bit more information on it other than just a 0 and 1. So I'm going to use the pick button, and let's get rid of those Z values. They certainly clog up this system for a moment. And I'm going to go pick our polygon. That's the polygon that we used in Roadflow to define the material types or the changes in N. I'm going to go accept that. And you'll notice that it comes up and says that it is a materials polygon. So 12D's looked at it. It's already noticed what it is. It's come down and it shows us the attribute. So that's exactly the status. But then it's gone and done a few extra things. It's gone and told us about 2 other databases. Now, if I go take a browse, I want to show you where these databases come from. So let me just go browse out of here for a moment, go into my culvert, into the classic setup, and there's the materials and roughness database. And it gives us the full path. Now, I'm a person who likes relative paths, so I'm going to go switch that to relative. Now, you don't have to do that, but that makes a whole lot more sense to me. And I want to go take a look now at that database. So if I hit the open button, it launches Excel for me, and I can see the database that's inside. Now, if I wanted to add more material types, I'd have no trouble. I could come and add a third one on here, and I could call this one gravel, and I might want to put a, oops, put that across there under gravel, and I might color that a really strange color like yellow, and give it a roughness. Now, if it's going to be some gravel, that might be around, oh, say a 0.027, too accurate for our modeling. And that would almost work, except these last 2 columns, TUFLOW's not interested, and we want TUFLOW to ignore them. And the way we ask TUFLOW to ignore them is by putting an exclamation mark in front of them. Now we're saying, why would we put information in that TUFLOW would ignore? Because 12D is going to use it. So I'm going to go save that. And I'm going to go, yes, I do want to keep that format. And I'll close that down. And I'll come back here. And what I'm going to do now is, that's my main database. This string database we don't need for the materials. So I'm just going to erase that and hit the Set button. Now what 12D has done, remember that color that was inside the materials? It's used that to fill in that polygon. It's also gone and labeled up that polygon with the ID, which is the 2, the end value that I had for it, and there's the description from that file. So that's automatically all happened. Now, it's not very helpful when you only have one polygon, but when you start having hundreds of polygons and you want to know the end values or the roughness categories or the material categories for them all, having them labeled and colored is a very handy feature. And also, if you didn't like the labels or you wanted to change the sizes, you'd be more than welcome to come down and change your label style there. So, an introduction to the TUFLOW String Editor, a whole lot more powerful. It does a lot of extra features, creating these links between your main databases and your strings so that they're easily accessible. And then, of course, once we hit the Set button, if I was to close that, the next time I come back to my string editor, and it remembers all those settings and makes it very quick and easy to get back to the main database. Now, that's just beginning of the TUFLOW String Editor. One of the things I did there with that TUFLOW String Editor is I used a string that was already created from Roadflow. But there's a whole lot of strings and string types or purposes that TUFLOW have that are not Roadflow. So let's jump back to our notes here and see what comes next. The world of empty files and empty models. And I remember the first time I explained this to a few people, saying that, you know, it's really important that we read these empty files into 12D. And I would get the looks like, why do you want to read empty files? And I said, well, because I want to create empty models. And that didn't help. And an empty model, of course, that we're referring to is that it doesn't have any strings. But these empty models are going to have the attribute signatures that we need. So let's take a look at converting TUFLOW's empty files into a 12D empty model. So back into 12D for a moment, and we'll just park this one to the side for a moment. And at the very bottom of our TUFLOW, and I realize I have skipped quite a few down here, we've got the create empty models. Now, at this moment, if you were to go back and jump onto your 12D model going, hey, let me take a look at that create empty models, you're not going to find it. Bit disappointing. 12D is about to release version M. That's M for Michael, you can see up there. And you're going to have to wait for that release in order to get the this feature. So what happens here is we give you an option. What a funny name for model prefix, Z space. And the reason I encourage you to use that, if I just go hit the process button, it's going to run TUFLOW. That was the TUFLOW black window that came up. And we ran it with the commands to create the empty files. Once those empty files were created, we read them back into 12D to create empty models. So let's see what we've gone and done. We can finish that one up. And let's go take a look at our model list. So let's go to our model manager. I'll hit the plus button on that so you can see what we have here. If I go all the way down to the bottom of my project models, I'm going to have to take you there another way. Let's go to the plus button. And I'll go Z space. And there's all those models. It looks like our model manager doesn't like to show us empty models. If we come down here, you'll notice that there's the Z. Now, the reason I chose the Z was so that these empty models would appear at the bottom of the list and not clutter up all of our work. But let's say, for example, that we were interested in creating an initial water level model. Well, what I'd come down here, I can see, look, yes, well and truly, we've got a new one there called Z2D Initial Water Levels. So the first thing I would want to do is to change the name to get more appropriate to my project. And remember that I was suggested that our model names become file names. So the first thing I would do is I would come up to models, come down to rename, go into my model list, put in my Z spaces, or even better in this case, my IWL, initial water level, and pick my empty model. And I'm going to change that name to something more meaningful. I'm going to call it TUFLOW, which is my prefix, initial water level, and rename that. Now, some people like to copy the models, but I figured it's so darn, if I needed another initial water level model for some particular reason, I could just go rerun that same function and get myself a new set. So I have no fear of shortage on empty models, so I'm going to hit the finish button now. And now what I'd like to do is to create a new initial water level string. So let's move back now. I'm going to go to the survey, and our surveyors have very kindly gone and picked up an area of a water level behind a dam. And I'm thinking that would be the perfect string to use. It may not be the perfect string, but it's a good start. So the first thing I'd like to do is take a copy of that string and put it into that model. So I'm going to use my strings edit, duplicate. So I'm going to take a copy of that surveyed string. I'm going to put it in my new model. My new model was called, if you remember, I can put IWL there. It was called TUFLOW IWL. So I'm going to use the start button there, come and pick that, accept it, and it says that that's been copied. So that's fantastic. I've got a new input model. So let's make that a little bit smaller. Let's go back to my world of inputs. I'm going to add in that new model called IWL onto my view just so that I can see where it is. And there she is. Now, the world of attributes. The initial water level from that is not read from the elevation. It's read from the string. So let's go pick it. TUFLOW String Editor, I'm going to pick that. And the moment I pick it, you'll notice it comes up with this new option. And it says, first of all, it does have an initial water level. It's got to figure out that value pretty quick. And then it came up and it said that it came from a model attribute template. And I'll talk more about that later, but essentially that's what's inside those empty models. This default names, and actually the default data as well, is stored with the model. Now that's not the initial elevation. I don't want an initial elevation of 0 on that. So what I'm going to do is I'll do a string inquire. Let's see what the surveyors picked up. They said that the elevation on that was 36.96. So that's when I would go put that in. So my 36.96 was the water level behind the dam. And I can go hit the set button. Now, before it hits the set button, it says, wait a second. This is the very first time you've ever used a string like this inside the model. So we ask you to push one extra button. We go update the model purpose. You only do that the first time. And now that well and truly sets this model to only be used for initial water levels. So that is the way that 12D model goes and uses the empty models from TUFLOW, empty files from TUFLOW to create empty models inside 12D. So recap on that, run the routine, rename the empty model, add your strings, and then use the TUFLOW String Editor to update the purpose and the values. So welcome to the world of empty models and empty files. Now, 902 errors. Sounds like a strange number, probably doesn't mean anything to anybody, except strikes fear into the heart of a TUFLOW modeler. That is an instability error model. And in our current version, depending upon the size of your project, if you get an instability, it can generate a great number of error messages. So let's start taking a look at these error messages and what we want to do and how we might investigate them. So I'm going to hit the finish button on that for a moment. And before I hit the run, I would like to go include this initial water level as a command inside my TCF file. So I'm going to go back to my editor. It's time for a new command. Now, this command I know goes into my TCF file. Okay, so I've gone in here, I'm at the TCF level, and I'm going to add a new command. So I'm going to go create. And right now it says no command, so I have to go and select the command I want. And the one I want begins with an R. I'm looking for a read command. Now I don't get to type RE, I just have to keep hitting the R until I find the one I want. And there's several different flavors that I can use for this one. The read MI, initial water level, is the perfect one for this case. So I select that, and then right away 12D goes and populates the required inputs for that. Well, we know the model that we want to use. The model that we wanted to use was our TUFLOW initial water level, so IWL. There she is. And you'll notice that we automatically populate a file of the same name. Now, here's we get into the world of file structures for TUFLOW modelers. They wouldn't want that file to be in the same folder as their TCF file. And that's what would happen if we left it the way it is. Let's go see what a typical TUFLOW modeler would use for a path to get to that. So I'm going to go work out my way into my culvert. I'm going to find my TCF file. So watch carefully how I get from my TCF file to the location that most TUFLOW modelers would keep their model files. So first of all, you'll notice I'm going to go up one level. Then I'm going to go into Model and then MI. So up one level, Model, MI. Now, if my typing was particularly bad today, I could go and just take a copy of that part and then work back into 12D. Now, to go up a level, backslash, and then if I pasted that path in, there would be the command that most TUFLOW modelers, or the path that most TUFLOW modelers would want to use in order to get that file exactly where they want it. Now, this time, I have changed the command file, so I would want to write it out. Not only would I want to write it out, I think, well, let's do that. We definitely want to write it out. But the other thing we'd like to do is to come down to our geometry. And if you remember, we put that stop button on there. I think it'd be time to get rid of that stop because we do want to do a run this time. So let's go and write that out and we'll replace that. And if we go do a run DP now, what it's going to do that run, but it's going to do a run using that initial water level. So they expect that to slightly change the results, not a whole lot, of course, but just a little bit. So we'll just let that finish up. Now, when I chose that, you might have noticed that I said that it might be a good string to choose. I was working on a 5-meter grid cell, and that means that when I set the initial water levels, I'm going to be setting them for 5-meter grid cells. So there's a possibility that that string may not intersect any of the crosshairs of a TUFLOW cell, but I think we're going to be all right in this case. So that's gone and finished. Of course, the first thing I'll want to do is go read my results. Oops, that's right there. And then I also want to go read my check files. Those files have been read back in. And if I want to take a look at what's happening around in this region, what I might do is create myself another view. So I'm going to go to View, Create, and I'm going to create another plan view. And I'm going to call this 2D velocity, because I'd like to take a look at the velocities in that area. The model that I'd like to add on, if I type in results, is going to be my velocity results. I'll add those on. And to help me get into the correct location, let's go put that initial water level model on and zoom into this area. Now, I'd be expecting very low velocities around this area, and truly are. That's what we have. And if we were to take a look at the elevations now, let's go look at our TUFLOW results graphs. Now, this is going way back in time. Let's go take a look at those water levels. And let's go pick a location. And we said that we wanted to start at 26.96, I believe it was. And you'll see that what's happened there is we've got our starting water level, okay? And then once, of course, the rainfall from our rainfall on grid starts to enter, everything starts to rise. Now, I've chose a very, very simple example for our first one about how we go through the process of using, let me go back to our presentation here, of using an empty model, adding a string, using the TUFLOW String Editor to update the values, then going and running, putting the command into the TCF and then running it. Now that time we didn't get any instabilities. That's one of the things with TUFLOW is that when you do get instability, it's usually when you don't expect it. And when you want to get one, you don't. So let me talk a little bit more about the theory of what one might do if they did get an instability. So looking across here, let's go take a look at our TUFLOW messages. So once again, when we come back, we do the same thing, that read results. I'm not sure if I hit the read check files, but before I do, I'm going to turn on this Z points. Now you might have remembered the Z points from Roadflow, it was there as well. And when we hit the read check files, it goes and reads in the normal check files, but it also creates a 3D visualization of that, of the tin that TUFLOW sees. So let's go take a look at that. And keep in mind, what I want to do also is to look at these messages. So maybe I should continue down that messages line first. All right, so what happens to this messages file? The first thing it does is go into messages model. So let's go add that model onto my 2D check. So I'm going to move back in here. I'm going to toggle off those Z values for a moment. I'm going to add on a model called messages. And there it is. There's my check file messages. Now, you'll see it's gone and inserted a whole bunch of dots around here. And if I zoomed in close, I could read a message that came behind them. Now, that would be a very slow and quite inefficient way to take a look at them. A much faster way, and the way we suggest you take a look at messages, is to go up to models and come down to the string information table. And in the string information table, I'm going to hit that same model button. Let's get that messages file. And you'll see that every single one of the messages is listed there. Now, there's a few about overlapping Z points. There are going to be a lot of those. But there's one here that says, wait a sec, the cell center had to be lowered by 3.2 meters. And that was to line up with the culvert. I'm going, well, that's a lot. I should probably go investigate that one. So if I was to click onto that, I could come down now, zoom in a little bit closer. That great big crosshair tells me exactly where the message is and exactly what happened and where. So you can see how that just zooms us into exactly where we're interested in. And if we want to see in 3D the significance of that, what I'm going to do is create a 3D check view. So I'm going to my view, down to my create, and I'm going to create an OpenGL, perspective OpenGL, and I'm going to call this one 3D check. The tin I'm going to add this on is going to be one of our check files. So I'll type in CHK again. And it's a Z point one that I'm looking at now. Now there's its initial entry. It makes a whole lot more sense if you toggle on your shading. And I've got my highlight. And you can see it's very easy for me to zoom in. Now, in a 3D perspective on this one, you'll notice depending upon your perspective, okay, that highlight can be just a little bit misleading because it can be off just a bit. So if I was to zoom around and get us around closer to the top, we get a much better idea of where that's going to be. So you can see that we're into that region, and this is actually where the trouble is. So I'm going to zoom in a little bit closer. Let's go put that culvert on. So there's a stormwater culvert that we're using for the modeling, okay? And what you can see is on both sides here, there's been a big chunk taken out of the bank, okay? And if I was to come back to the plan view, let me come back to that plan, and let's go add on the same stormwater culvert. Okay. Now you can see there that it's much easier to see exactly which cell was the offending cell. It was the upstream end. And in that 3D view, you can see exactly what's happened there. So that 3D check file is absolutely one of the most, I think, the most beneficial tools that we have inside 12D for starting to look and find out what exactly is wrong with your 2D model. All right. Changing the cell size and the time step. Always a tricky topic inside TUFLOW modeling. And generally it will mean, well, it will always mean creating a new grid tin, but generally it will also mean a finer time step. So we'll need to change both of those. So we have to specify the size, specify a finer time step, and recreate the grid that's going to go across the TUFLOW. Now, that's just the start. You really do need to review your entire model, especially when you've got your interaction between your 1D and your 2D structures. So going to a finer time step is not always going to be a one click of the button. You are going to have to review your whole model. But let's go see what we have to do in order to get at least the new data ready for the review. So the first thing I'll do is I'm going to come back to my editor, and I'm going to the location where we specify the time step. So if I come along here, the cell size. There's my 5 meters. I'm going to bring that down to 2 meters. And once I've got that 2 meters in there, I'm going to move down, and I'm also going to alter my time step. That approximation of making your time step 1/2 of your cell size is a pretty good starting point. Okay, so we'll do that. We'll put that first one in there. Now this also means that we need to regenerate our data train model, the grid model that goes across. In order to do that, we're going to have to select the data train model so that a new grid tin can be created. So this is the first time I've come up here and I've said that we wanted to have this data train model in here. So this time when I go run DP, okay, it's going to say, oops, forgot to save. Fair enough. Let's go back and write that out. Replace and run DP. So now we're running up and running, and we're running a much finer grid. We're running a 2 meter grid, so we're going to expect this to take a while longer. And you'll notice that the moment it does fire up, it's going to give us an estimate of the time remaining. Now this says that it's going to take about 7 minutes. So maybe within that 7 minutes, I would like to go see what's going to happen with the results and monitor them along the way. So I'm going to minimize 12D, and I'm going to start up another copy of 12D. So while my engine's running, I'm going to create a new project. And the location for my new project is going to be in the same folder. I'm going to call it Monitor, and I'm going to tick off this box here. And this important part, we don't want to create a working folder. And I'll select New. Now that's going to create a new project. It's a little bit slower now because, of course, my computer's busy away solving a TUFLOW model at the same time. And this isn't something that you need to do each time. This is something you need to do just creating the model once, the monitor model. Now, I'd like to have some sort of indication of where I am in space. So I am going to go copy a couple of models from my other project. So I'm going to go to my copy project models, and I'm just going to go across to my original model that I'm running. And it would be really handy, I think, if I had my survey roads, if I work my way down here to my S's, if I had that survey road model, took a copy of that, and also that survey surface, that's the one that had all my paths in it, my waterways, and I took a copy of those. We can finish that. And if I just go add them onto my view, okay, then that would just give me a good frame of reference, and I'll go save that. So now it's time for me to go read in the results. Now, the place I'd want to go read in the results, I'm going to go straight back to my TCF Editor. I'm going to go take a browse for that. And it's going to sit in my culverts, my runs, and there it is. And you know how much I like using relative paths. It allows me to move my project later, so I'm going to switch that to relative. And you know what? This would be a good time to set a default. I'm getting tired of selecting that TCF. So I'm going to set my defaults and go read that in. Now, the other project is still happily running away. I can come in here now and say, look, I want to read results. It'll tell me to do the same thing, to go grab my log file, read results again, and it's gone and read the results. Now, this also might be a time where I want to just go double check my check files. So I could easily just go read my check files into this project as well. And we're doing this while it's being solved. Let's go take a look at the result controls now. So while I was doing all of that talking, it looks like there's 20 time steps. And if I want to see if 12D's gone any farther, TUFLOW's gone any farther, I can put on this tick box here that says monitor. And then periodically, 12D will do a peek into the results file to see if it's been updated. And you can see a few more time steps have been solved. So while all that's happening, if I want to take a look at those results, and let's say it's the velocities I'm interested in, I can come in here and I can ask for my velocity results. There they are. And if I zoom in a little bit closer to where my culvert is discharging back into my stream, I can see now that I'm moving along. I've got 25 solved now, so I can step forward. And I'm noticing that the velocities are getting slightly bigger, as I would expect, because there's more water being involved. And so I can sit here and I can watch my results as it's being solved. And I'm more than welcome just to leave this. And if I was running a TUFLOW job that was going to take hours to run, I could simply come back later and just take a look just to see how things are going. So we can do everything to those results that we're doing before. We could graph them. We could look at the contours, all those sorts of things while it's running. So we've gone and monitored that long run. And that brings us pretty well to the end of what I wanted to talk about today in this first of a series of advanced TUFLOW courses. Now, I am going to leave you with a little suspense because yes, that job is still running and it will take another 4 minutes to solve. But I think this is a great time now to open up the floor to some questions. And so Lisa, if we've had any questions during all of that training, now would be a great time to hear from people.
Thanks, Rob. I'm just going to read out one of these questions live because we're a little over time today. So Fung in Brisbane has asked how to deactivate cells located inside polygons within a 2D domain.
Okay, good question. Let me go finish this one then. And because I can't actually alter that project while it's running. So the question Fung was asking about revolves around the idea of active and inactive cells. So let me go back to the correct project. That's what I'm looking for. And let's go ahead to our inputs. And what I'd like to do is to add a new model, and a new model is going to create active zones. So, or active or inactive zones. Now, let's say that it's an area out in this area here that I want to make inactive. Well, the first thing I would do is to create myself a new model, and I'd call that TUFLOW inactive. And I would go, now, I could start with one of my empty models, and that probably would be an easy thing to do as well. But because the inactive attributes are so simple, I think I might go with a shortcut there. Excuse me, let me just put that in the model field. That's much better. I tend to always like to give my strings names. And then my next job would be to create a polygon for my inactive area. So I would go and draw myself a polygon. Now I'm being very lazy at the moment. I'm just drawing a relatively random one. You would have a specific reason for wanting to make these inactive, and that's what you'd be looking for. So we have a new model, we have a new string. Now we have to set new attributes for it. So we go find our TUFLOW String Attribute Editor, go pick that string. And in this case, we do right inside here have a predefined one for cell active zones. So if I just pick that, it's going to right away go and know the proper attributes for this. Now, I don't want to turn them on. I want to turn them off. So what I would do is I would change that data value to a 0 and hit the set button. So now we've gone through, we've got the model, we've got the string with the attribute. The last thing we need to do is to be able to add that as a new command. So what I would do is I would go back up to my TCF file, and coming down to my geometry, I've got my set code. That's where we turn them all off. That's where we turn them all back on. And now what I want to do is to turn a few off. So the fastest way for me to do that is to take a copy of that command and just paste it back in. So now I have 2 of these. Of course, what I need to do now is to change the model. Now the model that I created up here, it's called TUFLOW inactive. So I might come up here and just type in inactive. Oops, too far on that. TUFLOW inactive. And remembering about how I was about making sure that my model names and my file names stayed the same, I'm going to go and I'm going to just replace that. Now I'm going to keep exactly the same path as before because we already knew where I wanted to keep them. I want to keep them in the MI folder. So there's the new command. Now, of course, I'd have to write that out. And yes, I definitely want to replace. And now I'd be ready to go run that again. So that's the sort of thing you'd want to do, Fung, if you wanted to add in a new model, okay, to turn them off. And I'll once again stress that the location of that was very important. It had to come after the command that turned them on. So that turned all of them on, and then inside that, we turned a few off. So hopefully that helped for you.
Thanks, Rob, and thanks to everyone for your questions. We've got some great training courses coming up in person for Brisbane, Melbourne and Perth. We've got a bit of a handout on the webinar here outlining what's in some of the courses, but there's just some of the dates that are coming up. You can register through the training page of our website or contact us by email for more information. The recording of today's webinar will be available in coming days through our website and our YouTube channels. Our next two training webinars are 12D field setout, drainage and other options on the 18th of April, and directional curb ramps on the 16th of May. So feel free to sign up for those and many more through our website. We'll keep you posted on that and everything else through email and social media if you're subscribed. If you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you all for attending, and we hope to see you at future webinars.